Hey, so we all see the magic of artificial intelligence everywhere, right? It's in our phones, our cars, it's changing everything. But behind all those algorithms and the crazy fast computations, there's a hidden physical cost. Today, we're going to pull back that curtain and look at the invisible but absolutely massive role that water plays in making the AI revolution happen.
Okay, so here's our game plan. We're going to start by uncovering AI's secret dependency on water. Then we'll get into the wild, super special kind of water it needs. After that, we'll look at why this whole problem is getting bigger, what's being done to fix it, and we'll wrap up with a really crucial question about the future of tech.
So, when you think about what powers AI, what comes to mind? Electricity, for sure. These giant server farms, yep. Brilliant lines of code, absolutely. You're right on all of those. But there's this other kind of surprising ingredient in the mix, a resource that's totally essential, but one we almost never think about.
All right, so let's kick things off by digging into this connection between the digital world of AI and the very physical world we live in. And this link, it's not just some minor detail. It's fundamental to how any of this technology is even possible in the first place.
Here it is, the hidden truth. Every single advanced semiconductor chip, we're talking the literal brain of any AI system, needs a staggering amount of water just to be manufactured. All that digital magic we love, it's physically born from this simple elemental resource.
But here's where it gets even crazier. We're not talking about the water from your tap or even fancy bottled spring water. No, no. The process of making a chip demands a substance that is so clean, it's almost unnatural. It's more of an engineered substance than it is just plain old water. They call it ultra-pure water, or UPW. And this stuff, it is so ridiculously filtered, so scrubbed of every single tiny contaminant, that just one microscopic particle or a stray mineral ion could completely destroy the complex nanoscale circuitry being etched onto a silicon wafer. It has to be absolutely perfect. And this ultra-pure water is basically the lifeblood of a chip factory. I mean, it's used constantly. It rinses the silicon wafers between the hundreds of delicate manufacturing steps. It's a key part of the chemical etching processes. And in the most advanced factories, they even use a layer of UPW to precisely focus light and print even smaller circuits. That's a process called immersion lithography. And if that wasn't enough, it's also needed to cool all the incredibly hot energy-guzzling equipment.
So as AI gets more and more powerful, its demand for this special water is just skyrocketing. This isn't a problem that's staying the same size. It's accelerating, and it's creating huge challenges for the tech industry and for the environment.
It's really like a triple threat. First, as AI chips get more complex and powerful, they need more layers, more intricate designs, which means more manufacturing steps and, yep, more water. Second, the sheer explosion in AI applications means we just need to make way more chips overall. And third, it's not just about making the chips. The giant data centers that train and run these AI models also gulp down enormous amounts of water just to keep from overheating.
And this creates such a stark contrast. On one hand, you have this image we all know, right? The futuristic, sterile clean room. But behind that shiny facade is this massive, kind of gritty industrial reality. These enormous plants whose whole job is to purify unimaginable amounts of water and then treat the chemical-filled wastewater that comes out the other side.
But this growing thirst is forcing the industry to get creative. Faced with this huge challenge, some of the leaders are already tackling it head-on. Take the world's biggest chip maker, TSMC. They've actually become a benchmark for sustainability, managing to recycle and reuse a pretty remarkable 87% of the water in their facilities. Now, to put that number into perspective, check this out. The industry average for water recycling, it's just 42%. So the top performers are more than doubling what the average company does. This shows what's possible, for sure, but it also really highlights how much room for improvement there is for everyone else. Okay, so this huge challenge hasn't gone unnoticed. In fact, it's kicked off a pretty high-stakes race to find innovative solutions. And it's not just happening inside the tech companies. It involves governments and environmental engineers all over the world. The approach to fixing this really has to be a team effort. It's about pushing the limits of water recycling technology. It's about inventing new manufacturing processes that are just plain more water efficient. It's about creating smart government policies and incentives that actually reward companies for conserving water. And really, it all has to start with getting an accurate measure of the water footprint in the first place.
And that really gets to the heart of it. This isn't a problem that one company or even one industry can solve on its own. It absolutely demands a coordinated global effort between the private companies building the tech and the public institutions that are in charge of our shared natural resources.
So all this leads us to the final and, maybe the most important question. As we stand here on the edge of this new technological age, we have to face the real-world consequences of the future we're building so incredibly fast. Ultimately, we're left with this fundamental conflict, aren't we? On one side, you have this incredible drive for technological progress that promises to solve so many of the world's problems. And on the other, there's this profound responsibility to protect our planet's most vital and, let's face it, finite resources, like water. And that leaves us with the one question that will define everything. Will the same spirit of innovation that gave us artificial intelligence also be able to provide the solutions to its own environmental impact? The answer to that is going to shape the true legacy of the entire AI age. Thanks for tuning in.